To finish our discussion in Chapter 4, I want to talk about a few additional reactions that we haven't already covered. But first, a quick review of what we have covered. So the first thing we've talked about is acid-base reactions. And this is where we have a proton donor plus a proton acceptor that will react with each other and do what's called an acid-base neutralization reaction. So this is, we looked at examples of like HCl plus KOH or something like that, right? Where we have our proton being donated by our strong acid, hydrochloric acid, and then our strong base is donating. It has hydroxide, which is a good proton acceptor, and those will react with each other. And then we have just talked about precipitation reactions. And this is where we take two soluble compounds, thinking about ionic compounds, and they'll form at least one insoluble product. Right, something that's a solid. Often a common product here in our acid-base reactions is water, plus other things that'll be present in both of these examples here. And so I wanted to talk about a couple of additional things that are actually involving acids. So they're still technically acid-base reactions, but maybe give products that you aren't quite expecting. And so let's start with an acid-base reaction involving carbonate. So carbonate is this ion, CO3 2-. And we can get either solids or soluble compounds. Either way, these reactions will occur regardless. But if we take a metal carbonate, so something like sodium carbonate, Na2CO3, sodium's a good cation to choose. Everything's going to be soluble with it. Though this reaction will work even if the carbonate is insoluble. And then if we react this with an acid, we will form carbon dioxide, gas, water, liquid, and then a salt. So I think doing an example makes this more clear. So let's look at sodium carbonate plus, let's pick a strong acid, HBr, hydrobromic acid. And this is still a double displacement reaction. We're still going to swap our partners here. So thinking about our sodium going with our bromide, as well as our, let's use green again, our carbonate going with our hydrogen. But what happens with reactions with carbonates is that what forms is our carbonate is a proton acceptor. That's our base in this reaction. And we'll form this acid. We need two hydrogens to balance out the charges, H2CO3. This is carbonic acid, if you remember your naming. But carbonic acid is unstable in water, and so it doesn't stay as carbonic acid. By the way, our other product here is sodium bromide, and this is a soluble compound. But what we're focusing on is the carbonic acid. This is unstable in water, and it doesn't stay as carbonic acid. And this is the way I remember what happens with these. This carbonic acid splits up spontaneously and forms carbon dioxide and water. And so that's why in this original equation, these are our products here. These come from our carbonic acid. So this is something to be aware of, and you'll see examples of this. This is your classic baking soda plus vinegar. So sodium bicarbonate plus acetic acid forming a bunch of bubbles. The volcano from like a science fair experiment or whatever. This is one of those reactions. So in that case, it's a bicarbonate. It's HCO3, but same idea. That acts as our base, and you have some acid that donates protons. It forms carbonic acid, which in turn dissociates into CO2 and H2O. Okay, so that's one to be aware of. It is just a regular acid-base reaction, but with this extra twist that you get carbon dioxide and water out of it. So just making you aware of that. Okay, another class of reactions that's also acid-base chemistry, but again, gives you slightly different things than you might expect, is looking at an acid combining with a metal oxide. Oxides being compounds that have O2 minus. Sorry, like this, O2 minus as the anion. So an example of this might be something like nitric acid. Again, I'm picking a strong acid, but it doesn't have to be a strong acid. It could be a weak acid. Plus, we'll just pick a metal, manganese oxide here. And for balancing purposes, there may be 2 of these. Right, this is aqueous, and this is actually a solid. So as we saw, oxides are solids with no exceptions. But this will react, and this will form the metal salt of the acid, plus water. So this is very similar to our acid-base neutralization reaction with hydroxide. So that O2 minus will accept 2 H pluses. So again, double displacement reaction. We're going to take our hydrogens and go with the oxides, and that's what's going to form our water. And then we'll use green again. Our nitrate and manganese are going to go together. But this will form a soluble compound because it's a nitrate. So this will be aqueous. We need 2 there. Okay, so so this is, again, an acid-base reaction, but with a little twist to it that you just need to remember. You add 2 hydrogens to the oxygen, and that will in turn form water. Let me make sure I'm not forgetting. I think there's one more here. Yeah, so the one last type of reaction, it's a little bit different, is, again, involving acids. So these are our additional reactions. And what we're looking at here is basically reactions that form a weak acid. Because weak acids don't dissociate, if we form a weak acid, it'll stay stuck together, and that is a reaction that happens. So let's look at an example here. Let's say we have calcium acetate. We need 2 of those. Reacting with hydroiodic acid. Should put my aqueuses here. So in this case, this is another acid-base reaction, and our acetate is going to act as our proton acceptor. So it's acetate plus H plus ion. It's going to come from our acid here. And again, I'll just highlight our other 2 that are going to swap places as well. So we will get HCH3CO2. And this will be aqueous, but it will not dissociate because it's a weak acid. And then we'll also get our calcium iodide. And this is not one of our exceptions with iodide, so this one's also aqueous. And so we're going to form a weak acid, and this is going to stay associated. And how do we know it's a weak acid? We know it's a weak acid because it's not on our list of strong acids. So that's how you would know that. And ones to watch out for this in particular are acetate, oxalate. These are both will form acids if they have H plus added to them from our list of common ions. There are more than this, but those are a couple of examples that we can see. Okay, so that's one additional type of reaction. So these are our reactions we're going to be looking at. We're going to be looking for acid-base reactions, so H plus OH minus in particular, but then some of these other ones involving, say, carbonate or oxides or this formation of weak acids here. And then we'll also be looking at precipitation reactions, adding 2 soluble compounds and getting an insoluble compound out. And those are going to cover pretty much the reactions we're going to look at in this class. There are lots of other types of reactions in chemistry, but this is a good basis to start off of. And so in your textbook, you may notice there's an additional section on oxidation reduction reactions. We're not going to cover those in this class at this time. You will get to that, but probably not until second semester. But that is, we're going to hold off for right now and focus instead on acid-base chemistry and precipitation reactions. And that concludes chapter 4.